Hi everyone. Today what we're going to look at is we're going to look at how black and white images are represented. And using a widget on the Code Studio, you're going to see how you can represent each pixel of an image with a black or white light. Okay, and we're going to talk about how the number of bits and the number of pixels that you use help to determine the clarity of the picture. So to get started, I want you to think about, want you to pretend that you have recently done some online shopping and you're expecting the package to arrive in about a month. And the delivery service has a tracking system and it needs the location of the package. How often do you want the location read? I guess it depends on how anxious you are for the package, right? So do you want it every week, every day, every hour, every minute? And depending on the frequency of how often you want to check, why? Why do you want to check? And once you've done this, we'll talk about it for a minute, and we'll have talked about it for a minute in class. And I want you to, think about why it is you might have wanted more specificity. And depending, and, probably you'll have found after sharing with a partner or the class that it really depended on the situation. Sometimes we would want to take a reading of a location more frequently if it's something that's really important and you need something or there's a time constraint. Today we're going to learn about how images are represented in computers, but I want you, as we're doing that, to keep in mind the idea about how often you're taking a reading or a measurement or the specificity that might come in handy versus just in general needing to track information. Okay, so let's move along here. And this is just the question I just read. Okay, let's watch this quick video.
My name's Lydia Choi. I work for Oculus as a technical art director, and I'm currently working on virtual reality hardware.
It's kind of like a baseball cap, so it's kind of like this motion.
Okay. And then you flip down the headset. Current thing that we're building is a virtual reality sculpting tool, trying to simulate like clay sculpting in space. Welcome to the pixelation widget, where you will encode a black and white image by typing out the binary yourself. Don't worry, it's easier and more fun than you might think. In this widget, the first 2 bytes, 16 bits of data, are used to define the width and height of the image you want to encode. The first 8 bits define the width and the second 8 bits the height. You have to type out all the bits, but the widget
This will
shows
not
you
be
the
true
decimal
for us
translation,
anymore.
so you
We
can
have a
make
newer
sure you're
version.
typing the numbers you want. To make it easier to keep track of where you're typing, you can add spaces and line breaks to the binary code. The widget doesn't pay attention to them, it just interprets the bits that are there. And now it's easier for me to see which bits I need to change to set the width and height I want. I'm going to make a very small image that's just 4 pixels by 4 pixels. Now the fun part. After we've set the width and height of the image, the next bits we type are the bits that define how the pixels are colored. We're just working in black and white for now, so keep it simple, 1 bit per pixel. In digital images, we define color in terms of light, and we can turn the lights behind each pixel on or off. So we let a 1 mean turn the light on, which gives us white. A 0 means turn the light off, which gives us black. Did you notice that I added line breaks when I was typing so that I could keep track of the row I was working on? That's a handy trick, and we actually have buttons that will help you with that. If you click the raw format button, it will strip out all the spaces and line breaks so you can see what the raw binary code looks like. The Readable Format button will reinsert spaces and line breaks to make it easier to read and edit. If you screw up your spacing or get lost in the bits, you can always hit Format and it will clean things up for you. Let's look at an example of a bigger black and white image. If you click Actual Size, it will show you what your image looks like when using the real pixels on your computer. For images here, it's probably going to be pretty small. Lastly, you can save the wonderful image you've made by clicking Save PNG. This will take the current state of your canvas, whether you're zoomed in or showing actual size, and popped into a new window. You can drag the image from there to your computer or save it in some other way.
Okay, I do want to point out to you that in the newer widget for this year, you will not have to kind of encode the width and the height of your canvas using binary. So that's called metadata, and there'll just be a slider. You'll find a slider in the more updated widget. Okay, so in this next step of the pixelation widget, we're going to, you're going to recreate the letter A using black and white images, like on or off. And you must first enter the first correct binary numbers to represent the width and height of the image. But you can use the slider. As you can see up at the top, you use the slider. You don't have to put in, you don't have to figure it out with binary. Then you're going to type the appropriate bit for each portion of the image, a 0 for black and a 1 for white. And for the next level, you're going to find and delete the extra bit that is causing the image to be distorted. They're going to purposely kind of screw you up with that. So that's what I want everyone to work on for a moment. If you're working asynchronously and you're looking at this video after the fact, then you will go ahead and hit pause and work on this in the widget and then come back. Okay, so challenges A and B, before we actually get into the activity guide, I just want you to think about the fact that now that you've had a chance to see how each pixel, how to set each pixel black or white, we're going to use the widget to represent an analog image using a process called sampling. And an analog image, it's a term used to mean something with continuous representation. Imagine a picture that you draw on a piece of paper. Each pencil line will smoothly connect to the next, no matter how much you zoomed in on the picture with a magnifying glass. As you know, this is not the case, with computers. When we represent an analog image digitally, we'll have to make some choices on how to sample the image to get the smoothest representation possible while still keeping in mind the number of bits it takes to build that image. So what does it mean to sample? We're going to choose how small to make the section of the picture we're looking at when deciding whether to make it black or white. The smaller the sample, the more pixels required to represent that image. The larger samples require less pixels, but the image can become blurry when you do it that way. So you're going to play with this, and as you can see, on the activity guide, which I'm going to go to right now. Let me just find it here. Hold on. I have it on one of these. No. Okay, so here's the activity guide. I'll just read through this really quickly. To work to digitally represent the image below. Read each square of the image and fill in the response on the worksheet. Enter the bits in Code Studio and use the timer to keep track of how long it takes. Remember, each bit can only be either black or white. You will have to decide in each square. So if we're looking here, this box that has some white and some black, you're going to have to choose. Are you going to make that black or white? So, hopefully, once you do this and you plan this out with the widget, you'll see that this is not going to look like this on a canvas that is broken up this size. Okay, so I do want you to go through this and then talk about it. And then your challenge B brings you to, you know, a canvas that is different looking, right? You're going to use a sampling more frequently by reading the image using smaller squares. And once you do that, you're going to talk about how many bits were needed, how long it took you to build, how does the new digital image compare to the one that you just made before that. And finally, challenge C is select your favorite company logo. Decide how you're going to sample this logo using one of the grids below. Are you going to use, you know, a smaller sample or larger? And, you know, once you do that, let me get back to where we were over here. And so you'll make adjustments, and then you're going to share it with your classmates, okay? And see if they can recognize what logo you're trying to represent. Okay, so now that you have had the chance to, in challenges A and B, you and your partner practice sampling the same image twice, and you had to make some different decisions, what were the pros and cons of sampling an image more frequently? You know, there are several advantages and disadvantages when it comes to sampling more frequently by using smaller squares. We get a better approximation of the analog image when we do more frequent sampling, and it's a little easier to decide whether each square, when we're deciding whether they should be black or white, it's easier to decide when the boxes are smaller. However, it takes longer, and you needed a lot more bits. You know, we still got an image that didn't represent the image accurately enough, though. Fortunately, a computer does this process much more quickly than we can, and it can store thousands or even millions of bits to represent an analog image, so it can end up looking very, very clear to the naked eye. By this point, we've used bits to represent numbers, text, and images. The same sequence of bits can represent different types of data depending on the context. It all comes down to ones and zeros. Okay, and so the data with values that change continuously or smoothly over time, that's analog, right? Some examples of analog include music, colors, painting, or position of a sprinter during a race. And digital are the data that changes discretely through a finite set of possible values. So, you know, it's not really continuous. So it's how the question becomes is how continuous do we want it to appear, right? And when we're thinking back to our original question, you know, do you want to check on the package arriving frequently on a map? That would really then depend on the size of the map. If you only wanted to check on a package that was being delivered twice over whatever we had said the delivery time would be, then you don't need a map with a lot of detail on it. You might need a map of the United States, and, you know, it will just tell you where in the United States your package is. But if you wanted to check it every single day, you would probably need a map that showed, you know, streets and very specific locations. So it would be more detailed. Okay, thank you.